Well, now we're dealing with probability. And if you go to page 280, you'll see the definition of probability, which is the quotient of the number of successful outcomes divided by the total number of possible outcomes. So our first question is, compute the probability of tossing a six-sided die and getting a 2. Well, the probability, the number of successful outcomes is a 2, which is, there's only one 2 on a six-sided die, and the total number of possible outcomes, there's 6 different numbers on a six-sided die, so the probability is 1 over 6. Now let's do question 2. And if you pick one card at random from a standard deck of cards, what's the probability it will be a king? So the probability of a king equals, and how many kings are in a deck? Why, there's 4. And how many cards are in the deck? There's 52, and that reduces to 1 over 13. So that's the probability of picking a king. Now for number 3, it says, what's a six-sided die is rolled twice? What is the probability of showing a 6 on both rolls? Well, you can see the probability of independent events can be found on page 283. So the probability of a pair of 6s is, let's see, the probability of rolling a 6 on the first die is 1 over 6, and times the probability of rolling a 6 the second throw is 1 over 6, and that product is 1 over 36. When 2 events are independent and you want to find the probability of both occurring, it turns out it's the product of the 2 probabilities. And we're done. Well, now for question 4, and the question is, Bert and Ernie, and this will cover questions 4 through 8. Bert and Ernie each have a well-shuffled standard deck of 52 cards. They each draw 1 card from their own deck. Compute the probability that Bert and Ernie both draw an ace. Now, these are 2 independent events, and the probability of independent events occurring can be found on page 283. So the probability of Bert drawing an ace is there's 4 aces in a deck of 52 cards. So 4 possible successful outcomes over a total of 52 possible outcomes. Now times the probability is the same for Ernie for drawing this ace, and 4 out of 52, and those both reduce to 1 over 13, so we have 1 over 13 again, which equals 1 over 169. Now, number 5, Bert draws an ace. So the probability that Bert draws an ace is 1 over 13. And the probability that Ernie does not, well, there's 48 cards in the deck that are not aces, and out of 52 cards, which equals 1 over 13, and 48 over 52 reduces to 12 over 13. So that's going to equal 1 times 12 is 12, and 13 times 13 is 169. So there are our 2 probabilities. Now, let's go on to question 6. Neither Bert nor Ernie draws an ace. Well, the probability is going to equal, if neither one of them draw an ace, then there's 48 cards in the deck that are not aces. 48 out of 52 times 48 over 52, and that equals, they both reduce to 12 over 13. 12 over 13. And the product is, the probability is 144 over 169. So for 7, Bert and Ernie both draw a heart. Well, the probability of drawing a heart, there's 12 hearts in the, there's 13 hearts in the deck, in a deck, over 52 cards in the deck, and they're both going to draw a heart, so that's 13 over 52, and 13 over 52 reduces to 1 over 4, and multiplying 1 over 4, and so that probability will equal the product of these two independent events, which will be 1 over 16. So we have one more question to deal with, and that is 8. And Bert, for 8, Bert gets a card that is not a jack. So, and Ernie draws a card that is not a heart. So for 8, Bert draws a card that is not a jack. Well, it's not a jack. There's 48 cards in the deck that are not jacks, so that's 48 out of 52 cards. And Ernie draws a card that's not a heart. Well, there's, let's see, 39 cards in the deck that are not hearts, because there's 13 hearts, and 13 from 52 is 39. Now, each of these reduce. 48 over 52 reduces to 12 over 13, and 39 over 52 reduces to 3/4, and 3 times 12 is 36. And as a matter of fact, before I go that far, 4 goes into 12 3 times, and now 3 times 3 is 9, and 13 is our denominator, so the probability is 9 over 13, and we're done. So for question 10, we're asked to compute the probability of drawing a king of hearts or a queen from a deck. And this formula for finding the probability of A or B can be found on page 285. So the probability of drawing a king of hearts or a queen, king of hearts or a queen of, well, the probability of drawing a king of hearts is 1 over 52, because there's only one king of hearts in a deck, and the probability of drawing a queen is 4 over 52 minus the probability of, in one draw, drawing a king of hearts and a queen from the deck. That probability is 0. You're only going to draw one card, and there is no intersection of the two. So we have 1 plus 4 over 52, which equals 5 over 52. That does not reduce. That's our probability of drawing a king of hearts or a queen.